Hi everyone, once again I am Jason Victor Serenas of Stereophile, setting my glasses in place, and I am here with Cyril Hammer, who is both the CEO and the chief designer, the designer of Soulution, and Cliff Duffy of AXISS Audio, who handles, I believe, 12 different products?
Yes, that's right.
But this is the main solution room with the big stuff.
Yes.
And parting the scene so that the camera can show it. The big stuff includes the 717 amplifier, 717 monoblocks. I can do this. The 717 monoblocks that I will be reviewing, they're coming to my house soon, which amazingly, as big as they are, only weigh 50
kilogram, yeah.
Which is about 100 pounds?
A little over 100
little
pounds.
over 100. And the other solution gear that we have here is?
Well, we have the 760 DAC, which has been out for a little while, but then we have two of the latest pieces. We have the 727 preamplifier, and then the 757 is called a de-emphasis preamplifier, and it's because it's not all a phono stage or tape. It can really handle almost any EQ curve.
Great. And of course, I certainly know about the preamplifier because I've reviewed it and it is superb. And you're also using, so we just know about the system before we focus on there, you're using Telos earth grounding.
Yes.
What is this?
So on the right there, we have the Monster Power Station, which is a very, very almost overbuilt power conditioner, but it's been very, very effective. And then we have their earth grounding Monster, which we are doing a star ground off of the each of the boards, both right and left channel boards in the Soulution sources. It's grounding those and then providing noise filtering for the grounds.
Great. And then you have these really interesting diffusers.
Yes.
And just could you mention a bit about them?
Yeah, these are acoustic diffusers from a company called Nihon Onkyo Engineering. This is their Acoustic Grove system is the name of the, all the, devices arrayed. They're different on diffusing. As sound goes through, it's broken up and reflects back off of the wall or surface and gets diffused again, coming back the other way. So you don't lose energy because it's not absorbing it all, but it does really break up those first reflection points.
Great, great. And they work with spheres, which I know from way back when I went to, the lab in Washington State, that they've measured all the diffusers, and spheres work best for diffusion, far more than those little slats at different, stuff, which is really exciting. Okay, moving on and back to the monoblocks. Please, Cyril, tell me about them and what makes them different than what came before.
Well, in this amplifier, most probably everything is different from what there was before. There is no piece the same. Everything new. So there is a new power supply in there. There is a new amplifier circuit in there, which is a new, different concept on how we do amplification. And yeah, it has more, provides more negative feedback, more loop gain, which means more negative feedback control. It has higher bandwidth, lower noise. It's better in any of the, let's say, normal dimensions we would measure amplifiers, and it's because it's just a new design from ground up.
So I always wonder about the kind of the journey of an engineer. So is this a new concept for you, or that you built off the last one, or is it a case of new devices came that enabled you to do more, or a combination? What is your process? How did you end up here?
It's a bit both of both sides. I mean, the design philosophy of Soulution always was to be wide bandwidth. And now the wide bandwidth design is not made just like out of a joke. There is a reason to it. We strongly believe that the change in phase you have in the audio band, so if you have a low frequency or a high frequency signal, if they are not really coming out of the amplifier aligned in time, which is the phase response, there is a distortion to the signal. And this was first in the 710, then in the 711, in all the preamps. This was always the case that we have wide bandwidth to reduce these phase errors in the audio band. That's why we go this wide. Now we pushed the limits always higher, higher, higher for that reason, right? There is not, we do not believe that we can hear anything about above 100K me or 20K me anyways, not, but that's not the point. It's just, the point is to make the phase errors as minimal, as close to zero, right? That's the aim. So we follow the same path with the 717 versus the 711, but we just go one step further, and this was able with the design of, let's say, a new concept, how the amplification is done, but then of course also a new generation of operational amplifiers, of switch mode power supplies, of local linear regulators, tiny integrated devices which have extreme performance. So all this comes together and makes then the performance of that amplifier.
And how the predecessor to the 717 was the
711.
711. And unfortunate name perhaps because because of the U.S. chain, but nonetheless, although I've been there a lot, how long was the 711 in production before you moved to the 717?
It's about, well, the 711 as a model was in production maybe 6 to 7 years, but the 711 actually did evolve from the 710, and the 710 is in production since, well, the original design for 710 has been done in 2005. So it's
got it.
It's 20 years, right? So it's 20 years that we have. After that, we come up with a complete new design of the amplifier.
And do you find that how long do your products tend to stay in the line before you replace them?
It's usually 6 to 8 years. That's what we learned is good, right? If you change too fast, it's not so not well received by the market. But after a certain time, people just think, oh, now it's time for something new. Right.
But you really feel you have something new. You're just not doing it because the market wants something new.
That's really something. There's nothing the same in there as with the 711, and it really makes the sound, brings the sound to another level.
And we should say price.
Well, for the U.S. market, we have a price just under $120,000 if you only buy the amp. But to try to be kind for the people who buy systems, we give another $10,000 on each amp, so it's $109,000 if you also buy a 727 or 757.
Great, and we talked about this in another video, but AXISS has come out with a very strong policy around the tariffs.
Oh, yes.
Yes, which seem to change much faster than the seasons.
Oh, yes.
Yes, so please.
Well, I mean, we truly believe that it's best for the industry if we can try to give some stability to pricing. So we've really committed that, we think the tariffs will go up and down, but we're holding all of our prices fixed, for at least the next 6 months. We'll reevaluate later, but, our goal is to not put our customers through riding the tariff roller coaster.
And your product is made 100% in Switzerland. So you don't have Chinese products or anything in there, or do you have?
I cannot say no, because if you produce PCBs these days, so just the PCB board, most of the manufacturers who produce the high quality PCBs, they sit in China. I mean, of course, there's a few in Europe as well. You find there as well, but mostly these parts come from China. And then if you talk components, these components come from everywhere. There's a lot of components come from the US, others from Europe, from Israel, some from Taiwan. It's a wide variety of components going in there and countries involved into that.
So there's the other question, which is that some people develop a product based on the measurements. Some people develop it on the sound, some on both. What is your process?
We have our design goals, and we follow that until the product is finished, and we measure. And if the measurement do not fulfill the specs we set for the product, we go back to the design board. But once it fulfills the specs and we think it's okay from the measurement side, we listen to it. And then, of course, the discussion goes on, is it really what we expected, or is it not what we expected? And this is actually what a process which started with the 717. It's good that you bring up that point. We had our goals with that design, and we measured it and said, it's in some areas it's better, in others not. And okay, so we listened to it. And we listened to it and said, but it sounds much better. And then thinking about an engineering process started. Why is this the case? Why do we have, let's say, higher noise on the prototypes, maybe a little bit more distortion, but then we have maybe lower phase errors, and still it sounds better. What is going on? And then, of course, we went back to the design board, and took us about 6 months to figure out what actually happened, to then actually go the right way to really make the best out of it. So that's the way how we work. We don't do just, let's say, engineering for the sake of engineering. It should sound good, but when we understand that there is something we do not understand from the measurements, then we go back and try to understand what it is.
So in that 6-month period, from when you loved the sound, but were not so happy with the measurements, to the place where you really loved the measurements, did the sound remain consistent?
Yes, actually, we loved the sound, but we did not understand why the sound was, why we loved the sound. Right? So
right.
we were actually chasing to understand what is the design parameter which makes it sound good, although the measurements do not look that great. And this took us 6 months to understand.
So do we leave Stereophile's poor readership like now in suspense and suffering and not knowing what that was? Or is there any of that you can reveal without revealing your secrets? Because I know I'm not here on video to try, this is not a trial.
It comes back to what the design philosophy of Soulution always was. It was the influence of phase. So, and we just learned it's more important than we ever thought.
And this is really interesting because that was exactly the subject in the PS audio room that I was just in. Their stuff is on a different price point and all of that. But they were talking about the exact same thing, phase. And then I was in audio group Denmark room, and they were talking about how many recordings are out of phase and how important it is to have a phase adjustment and all of that. So it's phase.
Absolutely.
And do you want to, for people who are not very technical, in a short amount of time, can you actually tell people what you mean by phase for those who don't know it but just read this term all the time?
I mean, it's hard to, if you not technical, it's hard to describe. But I try to give an image, which may be technically wrong, but just to give an idea of it. If you think of a low frequency tone, which is a low frequency, a bass tone, and a high frequency tone of, let's say we have a drum. You kick a drum where it is there's low frequencies, and there's maybe you hit also the corner of the drum, so you have also high frequency content. And so this structure of frequencies which creates the sound of that kick or that hit on the drum, this has to move through the electronics, be amplified or attenuated, whatever, and leave the amplification in the exact same structure it was before. Not just that the frequencies should be there, but the waveform needs to look exactly the same, to be phase coherent, and to sound exactly the same. And the trouble is that whenever you go through an electronic, the electronic will not let these frequencies pass exactly the same way through the electronics, be it an amplifier or preamplifier, whatever, doesn't matter what it is. It always changes the phase of the higher frequencies in a different way that it changes the phase on the lower frequencies, which is just like, in a simple picture, like offsetting the timing of when these events happen. I mean, it's conceptually wrong what I say, but just to give you an idea of what it is, it's just slightly out of time. So the low frequency event appears earlier than the high frequency event. So as if you would move the tweeter of a speaker 2 millimeters to the front or the back. So everybody agrees that's not a good thing to do, but the same thing happens in electronics as well, in a much smaller way. And to adjust the phase means exactly that everything remains coherent in time.
Thank you. And coherence is what we always aim for.
Yes, absolutely.
In our writing and everything else. We've asked a bunch of questions. We've been pretty concise here, but I want to just give you freedom. What else do you want to say as opposed to being limited by my questions?
Well, and it's the 717, and it's a lot of technology in there, but in the end, it's a matter of listening to it to understand what this means and how it changes the sound. If I say, well, we reduce the phase error from 1 degree at 20 kilohertz to 0.2. You have no clue what this means. It's a spec which, wow, it's cool, it's good, or maybe whatever. But what this means in terms of change in the presentation of music, how much more musical, how much more direct, more live, how much closer you get to the performance. It's hard to understand from the specs, and you really should get out and listen to the product to understand what it does.
And I'm remembering now, you sent me a bunch of your favorite tracks.
Yes.
And a lot of them were really good with bass.
Yes.
You spent a lot of time with bass and making sure that they were very, very fast.
Yes.
So that's one thing that's important to you.
Yes.
I mean, I don't remember. So do you play an instrument as well?
I played piano, yeah.
And did you play it for a long time? Do you play it,
Yeah, since I was a kid.
Yeah, great.
Yeah.
Well, thank you very much.
Thank you,
This has
Jason.
been wonderful. Yay.